I had a wonderful email, and if you don't mind, I'm just going to reply through this medium just as a way to answer the general questions other families ask. One of the questions has to do with just standards and the framework in which I write math and science curriculum. I studied chemistry at the University of Wisconsin in Superior. My minor was in philosophy. There's a reason for that. It's partly because I wanted to do Christian apologetics in the field of science and faith. I love discussing the topic of how science and faith connect. Professor John Lennox is one of the main people that I've studied under in this particular field. But basically, science is the explanation we can get for certain things, as far as why do things fall, or why do planets behave the way they behave. But then faith gives us the explanation of agency as to how those things came to be in the first place. Now, that's the way most scientists back in the day believed it to be. Isaac Newton, James Clerk Maxwell, Michael Faraday, Robert Boyle, they all believed that kind of mindset. They were called natural philosophers before they were called scientists. But I say all of that to say, when I write math and science curriculum, I actually don't follow any standard per se, because I'm trying to get people to master math and get to calculus. Like, I have a vision, I have a goal. Everybody get to calculus for fun. Now, the Common Core State Standards came out around the time that I was doing my math project, part of my math project. And initially, when you look at the Common Core idea, people might think, oh, this is a great way to know what grade level you should focus on things. But here's the thing, math is not a grade-based subject, not at all. When Isaac Newton did the work that he did and Leonhard Euler, they literally would take the coursework and just master the material to learn the next thing. They were not bound by any grade levels, and I don't think anybody should. So I don't align my work to Common Core, and I don't plan to ever align it to Common Core or the next generation science standards, because I do not believe in secular science as a basis for instruction. Any science curriculum that would use evolution as a basis for science, I cannot align with, because naturalistic evolution, that's what I'm referring to, naturalistic macroevolution, explaining how you and I came to be, instead of looking at God creating the world and we are studying the world God has created. I cannot stand with such a curriculum. So therefore, all my science curriculum is lined up with scripture. In the beginning, God created the heavens and the earth. So when I see a bird flying, right, I'm gonna find a bird. When I see a bird flying or I see a caterpillar, I'm looking at God's creation and then talking about, look at the world God created that I can study. So I do not follow any framework that denies the creation of the heavens and the earth. And I do not follow any framework such as the Common Core that lowers the bar of mathematical expertise and excellence. I literally want every student to do calculus for fun. Like, I want every student to do linear algebra. I want every student to get up to 21 credits of math before they graduate high school. So that means that, and the Common Core doesn't even require people to do calculus. And that's just so sad. It's so sad, the low bar that education has taken in America. We value sports in America. We value all these things. And I play basketball, tennis, soccer, and ping pong. But what about excellence in education, America? You know, that's my plea to America. And so anyways, that's my heart's cry in curriculum writing, is how can we help every student to become who they were created to be? And I know some people don't want to become engineers or doctors or people that use excessive mathematics, but I do want them to get the tools that work for them to get to the highest levels of math, science, or whatever field they're working on. So yeah, I do not plan to change. I'm gonna keep my curriculum pretty straightforward, which is I take you from basic counting all the way to calculus. No matter what grade level you're on, I walk with you every step of the way. And if you get stuck on, for example, fraction addition, then we check all the prerequisites for that to help you master the concepts so that you can add fractions and you can work with fractions well. That's the way I teach mathematics. Yeah, so I don't plan to do anything with Common Core or next generation science standards. If I am going to do anything with curriculum, then my goal is really just to focus on, let me see, how do I explain this? My goal would be to focus on concepts. So let's say I'm working on fractions, then I will work on, if my textbook doesn't explain it clearly enough for you, then I will see if there's a different textbook that explains fractions well. But I focus on concepts specifically and how to master those concepts. So that's how I teach math. And that's the way Newton and some of these guys did it. They mastered the concepts and then they moved on to the next thing. Isaac Newton read Euclid's book, which is one of the books I have. I have Euclid's book, I have Euler's book. So I have some of the books of the original, mathematicians, the big names in math. And I want to teach people how to master the lessons from the masters, if that makes sense. Isaac Newton is ranked as the smartest man ever to live in the last 1,000 years. Newton was exceptional in his mathematics and physics. But there's two things people don't know about Newton. The first one is that Newton actually struggled to understand some of Descartes' writings. Like, he didn't just master it the first time he read it. He had to read it over several times. Number two, Newton actually did math until a certain level, and then he gave up on math. Well, he didn't give up on it, but he moved to civil service, and he worked for the mint of what's it called in England. He worked for the mint, so the people that deal with money, right? So Newton did math for a period of time. This brings us to a very interesting point, and I'm actually going to read a section from a book here that is very interesting. You can only do math at a high level up until a certain point, and then unfortunately you have to say goodbye at operating at that level. That's why we need our young people to do high levels of math at a younger age, because the older you get, you kind of get to a peak and then it begins to drop off. And Newton, we see that with Newton, we see that with a lot of mathematicians. They're not publishing high-level papers at 90 or 80. And so we need to inspire young people, give them the tools. I do a year-round teaching approach because I find out you can save 4 years of education by just doing summer school year-round and building on what you learn rather than spending time reviewing in the fall because of all you forgot in the summer. Those are some initial thoughts. If you don't mind, I just thought I would record a video, that way it can be helpful for other families that are looking at my math and science curriculum. My math curriculum, again, is it takes people from basic counting, or the resources I use, from basic counting all the way to calculus. Some of the resources I use are college textbooks that are written for people who didn't do as well in their math when they were in high school and middle school, if that makes sense. So like, there's a textbook from College of the Redwoods that talks about how to add, subtract, multiply, and divide in college. It's teaching it to them in college as a review from their middle school, high school days, because they're not ready for college math, right? So we have resources like that just have a bunch of examples. What I'm looking for is books that just have a lot of examples, and I am trying to act as like a conductor and a coach. Hey, turn left over there, turn right, yep, keep going. Yep, stop, go back, take a left. Because math shouldn't be frustrating. If you've mastered the prior concepts, then you should be able to move on to the next one. How about science? In my science approach, people do general science and get up to, we use the J. Wiles curriculum, Berean builders, science in the beginning, science in the ancient world, science in the scientific revolution, science in the age of reason, science in the industrial age, science in the atomic age. We do earth science. Well, then people could do earth science and then do chemistry, biology, physics. But in Nigeria, we actually did chemistry, biology, and physics at the same time 3 years in a row. And that's my ultimate goal in America, is to actually give those who want to be doctors, for example, a triple dose of chemistry, physics, and biology, so that when they go to college, they're only doing 2 years left. They finish the first 2 years of college while they're in high school, so that when they get to college, they're doing just the focus of their major. So for example, organic chemistry 1 and 2, physical chemistry 1 and 2, if they're going to be chemistry majors. So then they graduate college in 2 years and start going to medical school, right? So they go to medical school at 20. So maybe they get married younger, have children who can then, that's kind of the way, part of how I look at it, if they want to get married and if they're ready to be married and if they find the person, etc. But the point is, I don't like the idea of doing a traditional high school and then doing 4 years and then going to med school. Like, you just start getting quite old at that point. So why not just double up your high school and college at the same time? I hope this was helpful. Thanks for reaching out. I hope to keep raising the next generation of scientists, mathematicians, and thinkers who also know the history and philosophy of science and logic and theology. And I want to go back to the days of Newton and James Clerk Maxwell, people who will acknowledge that the heavens declare the glory of God. And that's how I teach math and science, recognizing the one who created all things. I'll make another video with The Mathematician's Apology by G.H. Hardy, which is a great book that talks about mathematics and its beauty. Have a blessed day.